There's a little, I don't know. They have plenty of.
So a pretty funny thing,
Oh yeah.
I started getting like text messages from like scammers,
Oh
like,
yeah. I get
"Hi,
them all the time.
Bob."
Oh yeah.
So I got
Totally.
two at like the same time,
Huh?
and then I basically I started a three-way text,
Oh,
and now they're going
you're
back and
like you two should
forth.
introduce each other. Welcome to the LabVIEW experiment. I'm your host, Sam Taggart from SAS Workshops. If you're a developer looking to unlock your potential and take your skills to the next level, then look no further. From freeing your imagination and experimenting with new ideas and workflows, to exploring aspects of software development you've never even considered before, I'm going to help you grow your craft so you can approach your work like an artist and have more fun with what you do. In my 15 years working with and training developers, I've helped dozens of individuals and organizations embrace a growth and learning mindset that allows us to overcome challenges and embrace failure as the essential learning experience it is. If you're ready for the philosophies, strategies, tips, and tricks that will unlock your creativity, then it's time to get to work.
So we're on. Are we live?
Yes, I think we are.
Cool.
So, yeah. This is Sam Taggart from the LabVIEW experiment, and I'm sitting across from Jim Kring,
Hi, Sam.
JKI. Hi. Yeah, so we just finished GDevCon in A.
Yeah, great event. Thanks for having everybody.
Great. Yeah. Thank you. Thank you guys for sponsoring too. I should
Yeah,
make sure
we're
I mention that.
happy to contribute to that and participate.
Yeah. So, what was your favorite presentation?
Um, Let me think about that. Honestly, I kind of just absorb them all. It's hard to pick a favorite. I always love Darren Nattinger's presentations where there's always a very, very practical
Mm-hmm.
element, and it's also very much oriented around kind of improvement, making things better. And so I always feel like watching Darren's presentations, I'm going to learn some new stuff and I'm going to take away some real gems there.
Yeah,
Yeah.
he's also got like a great stage presence. He's very engaging too.
Yeah,
Yeah.
absolutely.
Yeah. Sometimes, I think this year was really good, but I've seen presentations in the past where people get up and just kind of read slides and, it's
Mm,
kind of like that monotone voice. And he's very energetic and very much engages the audience and gets some more interaction. So,
yeah, absolutely.
yeah.
How about you? What was your favorite presentation?
I also liked Hunter's presentation. So I liked the fact that he touched on user interface. Q touched on user interface, but it was more that a whiz bang how to stuff, and it
Hmm.
was really fancy. And I like that stuff, and that's really
The
cool.
technical tools.
But
Yeah.
it was more technical, and
Hmm.
Hunter's was more about the people side of it and how to like
Mm,
the human side and the human interaction and how to actually like convey and communicate information,
yeah.
which I thought,
How to communicate.
yeah.
Yeah, probably one of the most important skills we can develop as humans.
Yeah, no, definitely
Yeah.
an important skill as humans. Important skill is writing code, though, too, right? Because you're communicating, like you're telling the computer what to do, but your code is also communicating what you're intending to do to the next person who comes along and reads it.
Absolutely. Yeah.
Yeah,
Writing code is a form of communicating in a very clear and structured manner.
yeah,
And thinking about yourself and others in the future who may have to maintain that.
yeah. Everybody who touches it, but then also the code also touches other people, right? So it touches the end users,
Mm.
and then sometimes even further. So, like if you're, for example, I used the other day is like if you're testing parts for a car or something,
Hmm.
you're not just your software is not just affecting the people who are doing the testing, but it's
Sure.
affecting the
Yeah.
consumers and the other people on the road even.
Mm.
If you sell faulty brakes, it affects the person who's driving the car and
Yeah.
whoever they happen to hit. So,
Yeah. Well, yeah. And I think, too, it's important to have integrity, right? And do a good job on things and be ethical. And then also, too, just communication can uncover all this value, right? Or help mitigate a lot of risk that happens when either people don't know what other people are doing or they don't necessarily, know what the goals are for a specific project, for example.
well, I think sometimes that's the hardest thing is figuring out what the goal is and what it should be and making sure everybody's on the same page and understands exactly what they're doing. Like maybe you've seen the comic where it's like somebody says, "Oh, I'm thinking of a shape," and one person's thinking of a circle and one's a square and one's a triangle. Like,
Oh,
all right,
yeah.
yeah, we agree. We're all thinking about a shape. And it's
Yeah.
like, yeah, well, okay, but now you go build it and you end up with some Frankenstein shape.
Yeah, absolutely. And then, so communicating, making sure everybody understands what was agreed upon. And then, yeah, just deciding, picking a scope, deciding, and then starting to do it and finish it.
Yeah, yeah. But it's interesting though, like you start to do it and then you finish it, but sometimes like it's like an iterative process. So code,
Yeah.
maybe in your world it actually gets done, but in my world it's like never done. It's like you design something and it's working, but then somebody has a great idea. Oh, let's add this, let's add that, or the market changes or the technology changes out from under it, and then all of a sudden we got to play catch up and make these changes.
Yeah, absolutely. And I think it's a function of like how long are the cycles, right? The iteration cycles, and what are the costs of the cycles, and yeah, there's some culture there too. But yeah, I think every project, like, it's good for it to kind of have an end and to know if we did what we said we're going to do,
Yep.
and then to then decide what's the next iteration going to look like. And you do a lot of work in Agile and
Yep.
stuff like that, so you know all about that.
Yeah, I've been very much trying to do as short an iteration as possible lately because I feel like that makes you more agile in like the little A sense, as in like, oh, if things change, I can change direction very easily. So
Cool. Well, I'm really curious about like what kind of stuff you want to talk about today. We talked a little bit about like the conference and presentations, and yeah, what are you curious about?
Well,
What's on your mind?
Well, I mean, specifically with you, I think the title of the podcast is LabVIEW Experiment. I know you do a lot of experimenting with Raspberry Picos and doing stuff in Python and other things. I'm sure I'm probably missing some stuff. There's probably way more going on than I know about. But
yeah, and there's things that I just are on my laptop that haven't been pushed to GitHub yet.
yeah,
I really enjoy experimenting, both the learning process, being able to kind of spend some time exploring things and like learning and building new tools is really, I think it's a very enjoyable exercise. So I've got a lot of little projects like that.
So when you're building new tools, what drives you? Is it something? Is it that you see somebody else struggling? You're like, I'm going to make their life better, or is it like an internal, like I have a need, so I build this tool for me, or what causes that?
Yeah, I think what drives that for me is just not wanting to do the same activity more than a few times, and then at that point, like, all the creativity sort of leaves the exercise. And so what then becomes more interesting and creative is to, identify ways to maybe automate that or build a tool so that you don't have to do the same activity multiple times. And then the idea that a tool, like if I'm doing this over and over, other people must be doing it over and over. So if I could share that with other people and even get their ideas and how they've done it, then we could all be more efficient together. And so I think what kind of drives that is wanting to kind of like spend more time in the creative space and less time in kind of the rote, mundane.
Yeah, spend more time doing the things that matter and really move the needle, I think sometimes.
Yeah, absolutely. And then, also too, in terms of like moving the needle, I think, sharing and collaborating and having more opportunities to do kind of the human interaction around creative problem solving and getting to support each other, like that feels like an important part of like moving the needle for me, as opposed to just like, cranking out widgets and getting stuff done.
Yeah. So how do you see collaboration in the LabVIEW community? Because I kind of see it. I see both sides. I see events like GDevCon. I see other things where people are collaborating. And then I also run into stuff where people are very closed off and like I'm in my own little walled garden and I don't share.
Yeah.
Like,
I think that's just part of, I think, different aspects. There's maybe capitalism is part of that. Like, oh, this is a great idea. I could use this to generate income, right? In which then I can do more things that I enjoy if I have more income because I have more free time, leisure time. And so there's probably the competitive aspect of, that gives you a market advantage. And then there's probably some like ego aspects. You and I were kind of chatting about that a little bit of like, I think we tend to overvalue our own ideas. And so we might tend to keep them quiet.
Yeah. So two thoughts I had. The first one was the scarcity mindset. I think it is this like scarcity mindset. Like, there's only so much. Like if I'm a consultant and I've got this secret sauce, if I share it with anybody, then they're going to take away from my market share.
Nobody's going to come ask me to solve problems for them.
Yeah, I think that's a large part of it too. And there was another one that just slipped my mind. Maybe it'll come to me again in a second.
Yeah, the scarcity mindset is definitely a cause of people kind of closing off and not sharing or working
Yeah.
together. Yeah.
Yeah, well, I think that was the second point I was going to make is that if you don't share your stuff, yes, okay, maybe you have it and you're the only one who has it and everybody comes to you. But as you mentioned earlier, like you're not improving what you're doing because you're not getting any outside influence. You're not getting any outside ideas.
Yeah.
For
Yeah.
example, both Casey and Enrique gave presentations on
Uh-huh.
their tools for like visualizing
Yeah. Uh-huh.
projects. But both of them mentioned that, yeah, I had this thing and then I showed it to somebody and they had this great idea. And now my tool does this, right?
Yeah.
And so it increased the value of their tool
They're
by sharing it.
cross-pollinating. Yeah.
Yeah.
And I think personally, I think it's great if actor framework improves
Yeah.
because the tooling is great, and the DQMH improves because the tooling's great,
Yeah.
and they kind of appeal to like a slightly,
Yep.
I don't want to say slightly different audience, but like slightly different projects or team
Mhm.
structures. And so it's generally just improving the tool sets,
Mhm.
and increasing kind of like the scope of what the community can do, and might even enable and encourage more people to come in. Yeah. And
Yeah.
it'll make both tools better.
Yeah. Well, exactly. And also, so Casey's tool's out there and he gets an idea, he improves it.
Hmm.
Well, then that can improve Enrique's tool and vice versa. And they
Yeah.
can kind of share that knowledge base and learn
Yeah.
how to do things.
And open source in a lot of ways is like this evolutionary ecosystem, right? Where it's like kind of the survival of the fittest, not just tool or project, but also the community, survival of the fittest kind of community around the development of the tool. And so, it is good for competing tools to come out that leverage new technology and maybe replace some stuff, and then cross pollination of ideas. So it's all part of it. Yeah.
Yeah. That's very interesting stuff.
Yeah.
So I noticed that those two people both were like, they had very similar approaches to solving, they were both solving the same problem in different frameworks.
Hmm.
And I wonder, like, what other, did you see any other commonalities where they were like, this presentation, they're both kind of solving the same problem? I didn't notice any, but I wasn't like paying as close attention to all the presentations as I probably should have. Kind of
Yeah, I
occupied.
don't have anything specific to mention with respect to the presentations. I think, I think, I mean, the commonalities that I see in general are just, people want easier and better tools that allow them to express their ideas
Mm-hmm.
and to visualize how things work
Mm-hmm.
so they can interact with it, and then to be able to affect positive change in an efficient manner.
Yeah.
And that everybody's tools are kind of trying to do that, and they're exploring kind of different ways, and they're doing it within different contexts.
Mm-hmm.
Right. Yeah.
So we talked about code and communication, but I kind
Yeah.
of see those tools as like a communication aid because it's helping to communicate what's going on with the system. Because it's
Yeah.
giving you a different way of visualizing and seeing that higher level picture.
Yeah, I agree completely. And I think that's why we all love LabVIEW. Probably, at least the people listening to this podcast, probably at least love LabVIEW a little bit. Picture's worth 1,000 words, and a block diagram is worth 1,000 lines of code, or something like that. I don't know.
Yeah, I don't know what the equivalence is, but yeah, definitely. The ability to just quickly look at a LabVIEW program and you see two parallel loops and you know they're running in parallel. Like that's just like, I find like visualizing stuff like that in text-based programming language is a little bit harder. Like you got the indentation a little bit, and maybe I just don't read enough text-based code. So.
Yeah. Well, so it's interesting because that's something that's happening a lot right now, is that text-based languages are adding more and more support for parallelism and concurrency. And so, yeah, a lot of text-based languages, you can, import like, some kind of like a task library or a process library. And then, you create a task, and its argument is the function that it's supposed to launch, and it runs it asynchronously.
Yep.
And then, you have something that is waiting
to catch
on
it,
all of, well, you pass it an array of tasks, and it waits till they're all done, and then it gives you an array of results. And I think the thing that is maybe kind of different or missing in those text-based tools is like kind of like the wiring, like Jeff's wire, the channel wire
stuff.
Yeah, to be able to kind of see kind of see the asynchronous
Yeah.
message connections distinctly from kind of the synchronous flow of stuff. And then, of course, there's event flow and things like that. That would be great too.
Did you see Derek's channel wire thing?
I've seen some of that
very
stuff.
interesting. Yeah, so you had a channel wire where you set up the
Mhm.
channel wire, but you don't tell it whether it's like a queue or notify, or whether it's lossy, lossless, or whatever.
Mhm.
And then the readers, and it looked like every time you fork the wire, I guess it creates another reader.
Mhm.
That looked very, very interesting. Like that, in my mind, that opened up a lot of possibilities. Like sometimes, like particularly if you're using a particular framework,
Mhm.
like you're using Active Framework, everything's queue based, so it's lossless, right? But maybe what if you want to send something lossy? Like, how do you do that?
Mhm.
And that just seems like a very interesting way to do it.
Yeah, that is cool. I think the channel wire and the idea that one can like script code behind the scenes
Mm-hmm.
is a very important concept, because I think that one of the big areas that we spend a lot of time as LabVIEW developers is like maintaining template code. And I think that that's probably why, DQMH and Active Framework and other tools are popular, is, because you don't have to create as much template code.
Mm-hmm.
However, there still are like lots of ways in which, there needs to be a little bit of template code. And I'm just thinking, like, if like a dynamic dispatch VI, if you want to enforce like the call parent, whether it happens before or after, little things like that. Other text-based languages, I think, I don't do C or C++, but I know they have like macros, and things like Erlang Elixir have macros. Rust has macros, which essentially at compile time is sort of generating and extending modules at compile time.
That's interesting.
Yeah, and I think that that's really interesting. And it's kind of, I don't know, at least kind of tricky for LabVIEW, because it sort of seems like there really, isn't a whole lot of difference between source and compiled, because it's just so instantaneous.
Yeah, it happens instantaneous. Yeah, that's really interesting.
Yeah. And in LabVIEW, we just kind of expect it all to be so instantaneous, whereas in these other languages, I think people maybe don't mind as much waiting a minute or two between cycles. But I don't want to put words in their mouth.
No, yeah, I've played around with C a little bit, and like, yeah, the having to go through the compile step before you run it is just like LabVIEW. It's just like click the button and it runs, and you're like, oh,
yeah. And so you were chatting with me about the LabVIEW experiment and experimenting with things, and kind of seeing outside of our kind of LabVIEW world or echo chamber or context. And I'm definitely interested in talking with you about some of that stuff.
Yeah. So I've been trying to learn Python for a while. I haven't really had a good project to use it on, but I've been like playing around with like, was it the advent of code and solving some of those problems, which was really interesting.
Very cool.
And reading some books, and I feel like, they call them programming languages. So if you want to learn a regular language, the best way to go learn Spanish is to go live in Mexico or Spain or somebody, right? Yeah. And like do it every day and solve real problems with it.
Yeah. Same way with
like programming languages are the same way, right? Like
you need a pet project.
Yeah, I feel like what I'm doing is I'm reading the Spanish textbook, and that's all great, but I'm not getting the practice. Like I'm reading the Python textbook, and I kind of understand it, but to really get it.
They have some good sites and tools for learning to program interactively. Maybe the analog would be like Duolingo, right? For your phone, where it's a lot more interactive.
Yeah.
Where, you might watch a video, but a lot of text-based languages now can actually execute code in the browser.
Yeah, I've seen that. That's really interesting. And not having an IDE to download, nothing, and you could do it on your iPad or whatever. That sounds really interesting.
Yeah, so there's the WebAssembly technology, which essentially allows browsers to sort of like run compiled like bytecode in the browser in a very performant way. Is a great technology, and a lot of languages have built like WebAssemblies that can execute the language. And Python actually just recently released PyScript. Well, sorry, PyScript is and I'll probably get this wrong because I'm not an expert, but there's a Pyodide
Okay.
is I think the WebAssembly and the
Okay.
framework for actually executing
Yeah.
Python in the browser. And then it has hooks into JavaScript. And then PyScript, I believe, is a JavaScript framework on top of that lets you essentially insert snippets of
Python
Python
code,
code
it runs in the
in
browser
the
or something.
browser,
Yeah.
and it's got a library of functions that allows it to receive events and interact with the document object model
Wow.
of
Yeah.
HTML. So yeah, and it also makes it trivial to you copy paste this little block of code and it'll give you like a REPL.
Oh wow. In
Yeah.
the browser.
Yeah,
So
the interactive terminal
wow. Yeah.
for
Yeah.
Python in the browser. And when you're interacting with it, it can then be interacting with the actual HTML.
Yeah.
And so you can actually write little codes that
Yeah.
are interacting with the JavaScript and the HTML.
Yeah.
That's cool stuff.
It's very
I'd
cool.
love to be able to do that in LabVIEW.
Yeah. Well, I really like the REPL in Python. It's really easy to explore and try stuff. I kind of envision that as creating a new VI, right? Like you create a new VI, you drop you got something you want to play around with, you create a new VI, you drop it in there, you create the terminals, and you run it, and you press and press enter.
I'm glad you mentioned that because I've always felt that Python and LabVIEW share so many things in common, and I think that that's why they've both been pretty successful in the science and engineering community. I think with LabVIEW, you open your VI, which is kind of equivalent to creating a script.
Yep.
And then you can plop a few functions down, acquire some data, do an analysis, plot it. And in Python, kind of the same thing. You import your module, acquire some data, do a little math on it, and put it up in a Plotly window.
Yep.
And then you hit run in LabVIEW, and in Python, you just execute your script, and it's running. And then both of those tools then also let you, take those scripts and then, organize them in a project, build them into applications, distribute libraries and things like that. So they handle everything from I just want to sit down and type some commands. Mm-hmm. And then also interactively too, with a running LabVIEW program, mm-hmm. you can also open one of these scripts, a VI, mm-hmm. while your program is running. And of course, if you have the APIs into your program, yep. you can then write little scripts that interact with your running application.
Yeah.
Yeah. And then getting LabVIEW and Python working together is also an interesting, fun experiment.
Yeah, no, I'm sitting here watching you get really excited talking about this.
Yeah, I love this stuff. It's fun. It's fun.
No, that's I was trying to capture this when I gave me a little spiel day, but that's the kind of joy that I feel we should all have over programming. That little kid joy of hey, I typed something in the computer and I pressed a button and it did what I wanted it to do. I made the computer do something.
Yeah, I think, and I think we all, maybe we're all in a little bit of an echo chamber, and that we've kind of self-selected for we're the type of people that have fun doing that.
Yeah.
And there's other folks that have other things that maybe bring them more joy.
Yeah.
But yeah, I love geeking out and seeing how things work and building something new.
Yeah. So I have a weird question, but the alternative to having that joy is to have programming be a drag and kind of not as much fun. What determines what makes programming not so much fun, or is it always fun for you?
So that's a really good question. And, sometimes it varies day to day, kind of energy, interest, mood. I think, being able to work on new things, I think to be able to interact with people, for me personally, brings me joy. Being able to share, teach, being able to learn, being able to see that what I'm teaching or what I'm sharing or building mm-hmm. is going to bring meaning.
Mm-hmm.
Into the world. And I guess what that means is contributing to the joy of somebody else.
Yeah.
I think is helpful for that being a joyful exercise for me. And then it gets painful, when I'm basically just wasting time on the blue screens, the spinning wheels, the project that won't close, or project that won't open, and things like that, I would say are the joy killers.
Okay. Yeah, so things that are just unproductive and like kind of like interruptions and like get in the way kind
Yeah,
of thing. Yeah.
it
Disrupts
consumes
that
time,
flow.
which
Yeah.
is and then sometimes you lose some momentum because you were working on this
Yeah.
thing and you switch gears and lose some context. And
Yeah, that definitely happens to me. Like sometimes I'm going along and I'll hit a roadblock, and like for example, one of the things I was working with this company and they were sharing documents with me over like SharePoint, and
Mhm.
I'd have to go look something up in the document. I go to look it up. Oh, you got to send a code to my email and do this like 3-factor authentication or whatever. And like by
Yeah,
the time the email takes like 5 minutes to get there, and by the time it gets there, I'm like, wait, what was I going to look up again? It's like,
yeah, and was it worth it? Yeah,
yeah. I mean,
yeah, those are interesting problems, security and authentication workflows, and
yeah,
yeah. Um, And so I'm definitely interested in, chatting more about, Python and experimenting with like tools outside of
yeah,
LabVIEW. And um, that's, an area that I'm really interested in, kind of talking about more and sharing
yeah,
some of the stuff that I'm working
yeah.
on.
Yeah, so we were talking about the Pi
We're
Pico.
talking about the Pi Pico. Yeah. So the Pi Pico is Raspberry Pi's first microcontroller board. And so the Raspberry Pi, the first ones that came out, run Linux on a
Hmm.
microcontroller. And the Pi Pico is a microprocessor. And some different kind of like thoughts came together about like, well, what would it take to actually get LabVIEW running
Hmm.
down there? And I knew that the web VIs feature of NXG, which is now the G Web development system, that they have a runtime engine that's JavaScript based, and that they execute what's called a VI assembly, which is essentially just a text based language
Hmm.
for expressing parallel
Okay, so some
code.
kind of intermediate language.
Yeah,
Yeah.
exactly. It's like an intermediate language. And so we dug a bit deeper and then discovered that, that code base is written in C, C++, and then it's transpiled to JavaScript. I forget the tool, Ectum or something like that.
Okay.
Anyways, it uses some tool to transpile it. So after kind of digging in, all that code, the Vireo runtime engine,
Yep.
is open source. So, and I released it on GitHub in
Hmm.
their open source repository. And so we just went looking through the C, C++ code, and even saw like old experiments about like, could it run on a microcontroller or something? Commented out. And so, Derek and I worked together. Derek is a good C, C++ programmer, and we were able to pull in the Raspberry Pi Pico
Hmm.
SDK and then do a build output for the
Ah.
Pico. And then what we also did is we added a set of commands
Hmm.
into that Vireo runtime environment that's now going to run on the Pico microcontroller that executes your VI assembly code.
Okay.
And it does like the general purpose IO serial and stuff like that. And then what we did is we took the output of a GWeb VI when it builds it for the web.
Yeah.
It generates the VI assembly. We created a library of VIs in GWeb, which are stubs. They're empty,
Hmm.
but they have names like, write digital output, read digital input, all the functions that would be called at a low level on
Hmm.
the Pico. And then we have a preprocessor that sort of transforms the GWeb VI assembly into the VI assembly format that we're deploying down to the Pi Pico.
Hmm.
So that was kind of a fun experiment in like, what would it take and what's possible. And we did run into some
Yeah.
memory limits and things like that.
Cool.
So
No, that's really good.
yeah,
So what was driving that experiment? Was it just pure curiosity, or do you have a specific use case in mind? Or
well, I think part of it is just having this like long time desire to see like the limits of LabVIEW pushed. And, everybody who loves LabVIEW, I think, really loves it, at least in our community of advanced LabVIEW developers. They love it because it's a language.
Mm-hmm.
And they want to be able to interact with the world and express their ideas in this language. And for, long time, forever, LabVIEW has been very limited in terms of the types of applications you can deploy, how easy it is to deploy. And so I think there's this natural desire to see it kind of grow to be more than just a way to acquire, analyze, and present your results.
Yeah, I feel like since I've started using LabVIEW, a lot of things have come along that have kind of pushed that, object-oriented programming didn't exist for a while, and some of the new stuff, VIMs and things like that.
Language features, editor features.
Even though Darren said they were not, there were some issues there.
Yeah, I've seen some issues too, but I think that I hope that they continue to get better because they talk about getting rid of template code.
Yep. The OpenG stuff, I've seen
the
that
OpenG polymorphic
some of those have
VIs.
a lot of polymorphic VIs that could probably be replaced with one.
Well, in the way that we did the build process for those is we dynamically generated all the poly members.
Oh, wow.
Which now what the VIMs do essentially is they dynamically generate the members for you on the fly based on where you're calling it in your code and stuff, and that's way more powerful.
But I've definitely had that weird problem though where you have a Vim and it works, and then you open it up and for some reason all the wires are broken. You just delete them all and rewire it, and you're like, what happened?
So it's in some ways it's kind of it's experimenting and exploring well, what would it take? And so there's all these walls that we kind of hit, and we don't know how thick they are, how thin they are. And sometimes it's fun to kind of poke some holes.
So here's an interesting experiment. I haven't really tried it, but so the Python, right? You can call Python in LabVIEW, and Python functions by default. They're duck typed or whatever, right? So you can pass anything into them pretty much. But could you wrap that in a Vim and then you could pass you could have functions in LabVIEW that would basically accept whatever?
Yeah, that's an interesting idea. I'm not totally sure. And it's interesting that you mentioned that because one of the things that has been developing in the Python community is type annotations.
Yes. Yeah, they're kind of going the opposite way. They're trying to get some more of the strict typing, or at least the more hints about what's going on.
Yeah, the thing too is if you can do the type annotations, type hints, then all of a sudden the IDE can provide a lot more relevant information. Give it that to you. And then the other thing that it can do is it opens up a lot of opportunities for improving the execution performance.
Because it can optimize things. Because we're never going to go down that path, so we can just cut it out.
Yeah, and that's an area where Python, it's currently undergoing, and it's going to continue to undergo, it's got such widespread adoption now. Everybody's saying, why can't it run faster? And so there are folks working on the just-in-time JIT compilers, which will actually compile bytecode for parts, and if there are type annotations, it can actually compile much more optimal bytecode for those pieces. There's also tools like Cython.
The science
CYTHON.
Oh, C Python,
C Python is the different. C implementation of Python.
Cython
is a special tool that can basically transpiles your Python code into C if it has the right kind of annotation type hint comments, and then it can execute very performant code. And then there's C Python, which is implemented in C. Then there's, I don't know if I'm going to say it right, but PyPy, which is Python implemented in Python. Which actually runs a fair amount faster than the C Python. Because Python is so dynamic, they can actually do a lot more kind of tricks and optimizations.
Interesting.
Yeah, and then there's even Rust implementations of the Python language.
Yeah.
Yeah, it's cool. It's a wild world.
Well, I saw you mention Rust the other day
Yeah.
on LinkedIn or something, and yeah, I've looked at it. It's very interesting, but like that's as far as I've gone so far.
Yeah. I think for me personally, Rust is a little lower
Mm-hmm.
than I tend to go usually. Oftentimes like the management of the memory
Yep.
associated with my code isn't super important until I like run it and then see that there's a performance problem.
Yeah.
Because I'm not often doing microcontroller code or running, web processes that have to handle tens of thousands of connection transactions a
Yeah.
second or something. But yeah, so Rust, from what I understand, one of the big things that it aims to do is to have like memory safe
Yep.
programs. And so the language forces you from the very first steps to decide, is your data mutable?
Yep.
And then it also forces you to decide that you don't want your memory destroyed, your variables destroyed. So if you pass a variable to a function,
Mm-hmm.
you cannot access that variable by name after calling that function because its lifetime was passed into the function,
Yeah.
and that function owns it now. So when that function completes,
It's
it
gone.
goes away. And so, that makes it maybe a little bit slower. You have to be a lot more intentional. However, that forcing of intentionality, specifically around this topic of being memory safe,
Yep.
ends up creating more stable code that's very performant and also, helps avoid a lot of the security issues associated with like buffer overruns
Yes.
when the compiler isn't enforcing these things.
Yeah, C and C++ are kind of notorious for that, right? Like going off
Yeah,
the end of
yeah,
arrays and like not closing stuff and
yeah.
things hanging around in memory.
Yeah. And so it's interesting because I found like as I started reading about it and learning about Rust, in a lot of ways, like it kind of shares some ideas with LabVIEW.
Mm-hmm.
With LabVIEW, you've all your data for your clusters or objects is kind of kept together,
Mm-hmm.
and it kind of flows through your code in kind of a functional way. And so it just seemed like it shared a lot of kind of similarities in how LabVIEW is extremely type safe.
Yep.
Yes, very strict typed. Rust is extremely type strict.
Yeah. It's interesting.
Yeah. So I've been exploring that, and it seems too that a lot of the Python community, the hardcore folks, are starting to do a lot of low-level tool implementation in Rust and are building cool tools for if you want to create a Python module that calls some highly performant code.
Mm-hmm.
It makes it easy to essentially like generate the template for your little Rust module that then gets built into a Python module.
Oh, cool.
Yeah.
Yeah. So there's nothing in LabVIEW to call Rust or interact with Rust at all, right? As far as I haven't seen anything.
No, LabVIEW used to have a code interface node,
Mm-hmm.
which
The
would
CIN or whatever they call it.
yeah, the CIN, CIN.
Yeah.
And I think that I don't know when it was deprecated, but it's been deprecated, I think.
Yeah, for a while.
Yeah, and then so in LabVIEW, the way that we would call external code is DLLs.
Build it into DLL and then
Build
call
it
it DLL.
into a DLL and then you can call it. Yeah.
Yeah. That's cool.
Yeah. What other questions? What's interesting?
What's interesting? Very interested. So you talked about GitHub Actions.
Yeah.
Yeah. So I do a lot of stuff with GitLab, and it seemed like very similar to what GitLab is doing. Is it pretty much the same thing?
Well, yeah. So I think if I had to describe the differences between GitLab and GitHub, I would say that GitLab has a very kind of strong offering around continuous integration and delivery of products.
Mm-hmm. Yep.
And so they are addressing the needs of like a software product company
Mm-hmm.
that wants, automated test, automated build, automated deploy,
Mm-hmm.
staging, and they really want that workflow to be smooth. And so I think GitLab really kind of streamlines and simplifies things. It's very maybe opinionated about how you do it. And GitHub with GitHub Actions is, basically, hey, you can create these YAML script configs. You put them in this folder, and behind the scenes, GitHub finds them and sees that they say, hey, when these events occur
Yep.
in my project or externally, execute these jobs. And this, you can have jobs depend on other jobs. You can send events to other repositories. You can publish things. You can literally do just about anything. You can spin up a Docker image and run code in it. So it's just a very flexible set of tools for automating software processes. And there's a whole community of folks that have developed actions, and then also apps that maybe have like their own server that run things behind the scenes, that solve different problems in different ways. So it's much more of an open ecosystem that's not very opinionated about how you're going to do software engineering. And GitHub is really, since the beginning, really tried to appeal to like the open source community.
Yep.
And that's such a wide variety of projects, from like a person maybe sharing snippets of code or modules to whole communities building major software products. So yeah, GitHub's probably a little bit more of a general purpose flexible tool, and GitLab's very streamlined.
Okay. So I assume you guys are doing a lot of continuous integration and that type of stuff.
Yeah, absolutely. We have been doing work with Docker, and we're doing work to get LabVIEW running in Docker, both for Linux and Windows, doing work building like GitHub applications that interact with the APIs and spin up runners and execute tests.
Yeah.
And then getting some of the actions built up for doing things like executing unit tests with like Haraya or VI Tester, or building packages or executables. Even things like publishing NI packages to a feed that's hosted on like an S3 bucket.
Yeah.
All those kind of parts of build, deploy.
Very good.
Yeah, it's fun, interesting technology, and it feels like it's a bit of uncharted territory. So it's been a fun exploration.
Yeah, I find it's really can help streamline things. Like I have one project where I work on where basically I make a change and I just commit and tag it and I just walk away, and like it shows up on the customer's machine like in like 20 minutes.
It's
like
magic.
It's total magic.
Yeah.
And normally that would take me a long time to go through all those steps and manually, and they're error prone and all that. And it's just total magic.
Yeah. And if that stuff can be set up in a way that's fast to set up, and then also too that's kind of maintainable and reliable, that can just save so much time. And then also it can help avoid a lot of pain.
Yeah.
Well,
I was talking to Katya, and I feel like the CI stuff, it's kind of like a power screwdriver. Like if you just had to put in one screw, you wouldn't go out and buy a power screwdriver. You would just pick up a regular handheld screwdriver. But if you have the power screwdriver, you would use it. And I feel like the CI stuff, it's that burden of setting it up initially and getting things up and running. And once you have that figured out, then you can use it on all these tiny little projects. And even if it's a little project, I feel like there's still a lot of benefit. But there's not enough benefit of one individual project, like if it's really tiny, to like set it all up.
Well, so yes, absolutely. And I would mention that, especially in terms of getting things working with LabVIEW, that and in general, just moving into kind of that CI/CD space, like there's a lot of different technologies that you need to learn. Basically, there's a lot of things that happen like in a command line terminal. You'll need to think about like SSH keys or tokens and managing all that stuff, and
networking stuff, and like there's a whole lot of
if you want to run PowerShell scripts on a Windows computer, you have to like turn on certain developer settings, and then do you want to run like the GitHub Actions client or the GitLab Actions client? Do you want to run it as a service
Oh
behind the
yeah.
scenes, or do you want to actually run it in sort of the user's context? And when it's running as a service, you don't interact with the UIs, you don't see it,
Yeah.
and so there's and that's just like the tip of the iceberg. Then you get into understanding the YAML formats,
Oh yeah,
which
they
is
could be
its own
crazy.
programming
Yeah.
language. You have to understand some PowerShell. If you want to do Linux or Mac stuff, you need to know Bash shell. And so there's just all these different things one would need to understand to actually get it set up. And then you start thinking about like Docker. Are you going to run this in
Oh
virtual
yeah, that's
machines?
even worse. Yeah.
And and each one of these is like a whole kind of big thing one could spend a lot of time learning.
Yeah, it kind of makes you realize why some companies have like DevOps engineers who are just like all they do is set up these type of tool chains, which is
Yeah,
like because
absolutely.
it could totally be a full-time job in itself.
Yeah, and I think more and more companies are going to have like full-time
Yeah.
like DevOps people. And also too, there's going to be more and more folks like, purchasing
Yeah.
subscriptions to offerings from like, GitHub and other
Yep.
companies that are going to solve these problems for them.
Well, I think in the LabVIEW space, there is room for a consultant who would go around and just help people set these tools up. Because I feel like most places they would need some help in order to do that because they don't have like that whole breadth of expertise.
Yeah, that's
Yeah.
a good point. Absolutely. I think the the number of people who kind of know how to do it in the LabVIEW community is rather small, and there's lots of gotchas involved. And also too, it stands to bring a lot of value
Yeah.
into different projects and efforts in the community.
But also too, I feel like LabVIEW, like that whole tool chain, even for like regular code, like Python or something,
Mm-hmm.
it is difficult. But for LabVIEW, it's even more difficult because there's even more gotchas because of like the graphical nature of LabVIEW and trying to call stuff from the command line and
the big gotchas are it needs a user interface. It's a big download to install. So where are you going to store these containers?
Yeah,
and are you going to pay?
And it takes forever to install it, so you're not going to install it every time. And
for if you have private services for GitHub, you're paying by the minute that your runners are running, and you're paying by the gigabyte for the size of your images.
And if you're running your own server, that's a whole other ball game. And
and then you're worried about it rebooting itself and all these things. So it's a tough problem, and there's definitely some economies of scale that if you have big enough teams or you could offer that as a service that it's worth putting in the time to do it. And I think it would be great for the LabVIEW community to be able to push changes to a VI in a library and then just be able to like download their package or see it pop up in their repository.
I don't know, do you see a future in the LabVIEW community where there's like some sort of, or maybe it exists and I just don't know about, some sort of like documentation or like getting started with setting up GitLab and GitHub runners or whatever, and like here's all the steps to go through, like a tutorial type. Like I haven't really seen anything that goes through all the steps, or is it something where like every company's going to do it slightly differently? So
I think that's part of it. Is there's so many different ways to do it that it's hard to have kind of the definitive guide. I mean, one could document like, here's how I did it.
Yeah, exactly.
But it would be good to kind of have some prescriptive ways of doing it.
Well, I mean, think about like, I'm using GitLab, I'm using GitHub, I'm using Git, I'm using SVN, I'm using Jenkins. Like there's just all those options and trying to account for all that.
Yeah. And I think most LabVIEW developers just sort of want like, what's the good option that everybody's kind of figured out and that I can get questions answered by others when I have questions.
Yeah. So what is that answer?
What is the answer? I think, what I would say is for people who are interested in doing more software engineering in LabVIEW to just branch out a little bit. I've decided that one of the things that I want to do this year is get more involved in like the Python open source community. And, some of the tools I've been working on, there's opportunities for me to share some of my Python code with the community. I just published a GitHub action that builds standalone executables
I
from
saw
Python.
That looks awesome. I have yet to try it, but I was like, wow.
The only thing I really added to the mix was understanding how to set up a GitHub action
Yeah.
and sort of the interface to the tool, which is Nutka. I hope I'm pronouncing it right. But yeah, and just simplifying the API so that a Python programmer, they have their script, their PY file somewhere in their folder for their repository. They just create their action YAML and they call the action and pass it the path to that script. And this tool, this GitHub action will just generate an executable on Mac, Windows, or Linux, or all three at once if you want. And it's that simple.
That sounds like it'd be really useful for like little utility functions and stuff.
Yeah, that would be really helpful for small utilities. And the nice thing too is that like these are portable. You know, you take the executable and run it over on somebody else's computer and it just works.
Yeah.
It's pretty cool. Yeah.
Yeah.
And so, yeah, I've been wanting to. So my advice is, branch out, get involved. And I think there's just so much learning about how the wider, larger software development and open source community works, the tools that they have and the techniques that we could leverage in LabVIEW.
Yeah, I've learned a lot from studying Python and reading books and stuff. And there's lots of really good books and podcasts out there.
Yeah, absolutely. And it's always good to kind of learn different kind of frames of references, frames of reference. And, you're talking about, is it a square or is it a circle? And, then there's that old kind of cartoon that shows that actually depending on which angle you're looking at it, from one angle it's a square and the other angle it's a circle.
Yeah.
And so, and that's not so much miscommunication as the fact that neither side knows that it's looking at the same thing from different perspectives.
Yeah.
And so it's often helpful to put ourselves into different frames of reference so that we can better understand our own default frame of reference. Yeah.
Yeah. Well, I also think too, like when you read a book or you read a blog post or something, it helps to understand the context the person is coming from. Like what's their background? What do they do? Because, like some stuff comes out of if you're running a website, like the continuous integration, continuous deployment thing makes a lot of sense, right? Because you make a change, you want to see it on the website instantly, right? But for like some of the stuff that we do, so you need that little bit of gatekeeping, and you need that little bit of like, okay, I made this change. Now let me test it with the actual real hardware in a test cell and make sure it works first before I push it out.
Absolutely. And what's the impact and the cost of iteration too, or failure? Yeah.
Yeah.
But yeah, I got to keep experimenting and improving. Do you have any final questions? It seems like we're close to wrapping.
Yeah, I think we covered a lot of ground. It was really nice talking to you. I quite enjoyed it. Yeah.
Nice talking to you too, Sam.
Yeah, we should talk more often.
Absolutely. I'm looking forward to it.
All right, great. Thanks.
Thank you.
That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram at @TheLVExperiment so you never miss an episode. And remember, small steps and quick feedback are all you need. Catch you next time.